All right, let's get started. So are there any questions over homework? Because I said that there might be questions over homework.
Let me get it. Hold on. 29.
29.
Yes.
From 6.3 or 6.4? Because you said
4.
6.4? 29? Find the exact value without using a calculator? Does that sound right?
Yeah.
Log base 1/2 of 16. Here's the question, yes? All right, so what is this question asking us? 1/2 to what is 16? Right, that's what this means. So another way of writing that is this is equal to something we can call x, and then use that loop to rewrite this from logarithmic form to exponential form. So this is 1/2 raised to what power is 16, right? That's what that's saying.
Do you have to rewrite it?
What?
You just have to rewrite it?
That's one way to do it. Yeah. And because I'm raising the 1/2 to the x, right? I don't have to have the parentheses. I'm just trying to stress that the 1/2 is being raised to a power, yeah? So the way we did this previously is we tried to get these to be the same bases. And I think that's what's going to be a little confusing about this. You're trying to write it as a fraction. That's not what we need to do. We need to see, can we rewrite 16 as 1/2 to a power? That's pretty much asking the same exact question as what we were asking in the very beginning. So does 16 come from anything that you see in here? 2, right? It's 2 to what power? 4th power, isn't it? We know that 16, well, let's write it this way. This is 2 to the 4th, right? But we need this 2 to not be a 2. We need it to be a 1/2. So how can you rewrite 2 as 1/2? How about 1/2 to the -1? Now, does that make sense to you? 1/2 to the -1 means you flip the fraction over, right? So this is really 2, a fancy way of writing 2. Is that a fancy way of writing 2? Yes? And then I'm raising that to the 4th power. And so when you have something to a power, actually I just handed you a formula, set of formulas with a summary of all the different rules. This is in the exponent section. See the top section says exponents. I'm going to say here, this is exponent rule, which one? From here to here? Is it in here? 2. This is exponent rule number 2. Right, for this, what does this turn into? 1/2 to the -4. So 1/2 to the -4 equals 1/2 to the x, which means that x must equal -4. So your answer would be -4. Now there's another way to do this without doing all this, and it's the last thing I showed you in class, the change of base formula. You could have just started the problem and broke your calculator out. I know it says without, but I'm just saying like this could have been done this way. What would it be? Natural log 16 over natural log of 1/2. If you do that on your calculator, you should get something really close to -4. Any other questions?
43.
43? See, this is the type of problem I thought someone would ask about. Good. They give you a function, this number 43, from the homework from last class. They give you a function, f of x. It's defined to be natural log of 1 over x plus 1. And it's asking for the domain of this function. Domain. Okay, so we have to remember something here. about basic log functions. And this is what we discussed last class. Do we remember that exponential functions look like this? Or possibly like this? Depending on the a, depending on the base. That's what an exponential function looks like. It's either exponential growth or decay. Yeah? And then we said last class that when you graph a log function, it looks like this or possibly like this. And we have this vertical asymptote. And so when we did that, we said the domain of a log function was from 0 to infinity, right? 0 to infinity was the domain of a log. Sorry, I didn't put log here. Which means that can you plug 0 into a log function? No. Can you plug negative numbers into log functions? No. That means what you plug into the log function must be a positive number. Agreed? So this right here, this piece that you plug into the log function has to be greater than 0. Or else you can't do it, right? Do you all understand?
So that was the trick question?
No, it's recognizing that when you have a log function, no matter what it is, you have a restriction on your domain that whatever is inside the log has to be positive. Or else you cannot do it because the graph doesn't exist over here.
So where a can't equal 0, right?
Pardon me?
A can't equal 0?
Yes, or less than 0. So what we said for a log function, we said for all log functions, last class, this is what a general log function looks like. We said a must be greater than 0, but a could not be 1. Do you remember me saying that? Yes? But we also have a condition here that x must be greater than 0, which means that this, so it's not the a that's causing the problem here. It's the fact that what goes into the log function, the x, has to be positive. Now, just some language here. The thing that you plug into a function, all right? The thing that you plug into is called the argument. How do you spell it? M-E-N-T? Yeah, argument. I don't know why I wanted to put an E there. The argument of a function is the thing you're plugging into it, all right? So when you get to pre-cal, you'll be studying sine functions, cosine functions. These are these trigonometric functions. The thing that goes into the function is called the argument. So what we need for a log function is that its argument is always positive, all right? So I'm ready to answer the question and do the problem, but does everyone understand what I have to do? Yes?
So if it was a negative 2 in place of the x, you would have a negative 1 there, and that wouldn't work.
That wouldn't work.
Because,
You can't plug a negative into a log.
because what would it do on the graph?
Well, it wouldn't. Let's go back. Let's just take a log, okay? We'll come back and answer this. Let's just take a log and let me try and put a negative number in there. Let's start with this. Log base 2 of 8. Does everyone know what that is? 3, right? Because 2 to the third power is 8. Yes? Now let me try and plug a negative number in there instead. Negative 8. You're saying 2 to some power has to be negative 8, right? That's impossible. It's impossible because start giving me powers of 2, you know? You're never going to get a negative number. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8, right? If I try negative numbers, 2 to the negative 1, that's 1/2. 2 to the negative 2, that's 1/4. And we actually can graph this, right? 2 to the x, we could graph it, and it's never negative 8, right? It's never down here. So that's why, you know, it's impossible to put a negative into a log. Does that make a little more sense?
Makes sense.
Okay, good.
So I know one of the questions is like a fraction over a fraction is like a half.
Mm-hmm. Not this one?
63, that was a more explicit graph.
Oh, you're supposed to match? Is that what it is?
Yeah, like the exponential,
Okay.
it was a half. And
Okay, we can look at that after this.
Okay.
Okay. So for this, what I need, right, what I want here is I want my argument to be greater than 0, don't I? And guess what? We studied this. This is actually called a rational inequality. We did this a while back. And this is part of the reason why, is we want to be able to resolve what the domain of a log function was. So how do we do the rational inequality? Anyone remember how we do this? Okay, so we move everything over to one side. We get a common denominator, which we already have. We figure out where the top is 0, which doesn't happen. We figure out where the bottom is 0, which is what? Negative 1. And then what we did is we put that negative 1 on the number line. It's looking familiar? We picked test points. Negative 2 and what? 1? Okay, 1's fine. We take these, we plug these in and see if they're true. So if I put negative 2 in here, will this work? No, right? I'll get a negative number on this side. The negative number is not bigger than 0. So nothing over here works. We plug 1 in. Will 1 work? Yes, it does. So everything over here does work. That means everything from negative 1 to the right forever is going to be good for us. So our domain will be everything from negative 1 to infinity. So just remember that this right here, if you need to go back in your notes and look, this is called a rational inequality. Okay, so 63, you want me to talk about 63 also?
Yeah, I was just a little confused on that one.
Okay, so see what I can do on 63. Do my best to graph this here. So on 63, they give you a graph. Looks like this. And they want you to match this up to a function. They give you functions are what, A, B, C, D, E, F, G, H, and they're trying to match it to this picture. All right, so what do we know? We know that all log functions usually start off like this, right? That's what a log function looks like if the base is bigger than 1.
So it's going to be a negative
Well, when we flip it across
the y.
the x-axis, right, we just put a negative in front.
Yeah.
When we flip it across the y-axis, we put a negative in front of the x. Okay, so there's a difference. If I put log base a of x, okay, if we look at that and then we look at this one would flip it over the x-axis. Okay? If you do log base a of negative x, what it does is it flips it over the y-axis. Okay? So does this look like a flipping over the x or a flipping over the y? It looks like a flipping over the y. So do any of these have negatives inside? Which one? B? Do you know what the answer was?
No.
Yeah, it says the answer is B. So your choice for B is y equals log base 3 of negative x. That's the correct answer. So do you see why that's the correct choice now? Because it's the negative inside the log that gives you reflection over the y-axis.
Okay.
Okay? Let me compare that to look at choice D. Choice D was negative log base 3 of negative x.
That would be that.
There would be a double reflection. This would be a reflection over the y-axis followed by a reflection over the x-axis. So you would do this, and then that over the x. So this red one would be this one. Do you see the difference? Reflection over y followed by reflection over x. We good, Jordan?
Yes, sir.
Okay.
Appreciate it.
All right, let's get to today's stuff then. Properties of logs. If you have any other questions over that homework, because I know some of you didn't get to it, I'm happy to address those questions next class at the beginning, if you want, or come by my office for help. All right, this section is full of information, lots of formulas. So what I did is I found this on the web, so I didn't have to type it up myself. And it's just a summary of all the different properties of exponentials and logarithms. So I'll refer to this worksheet through the rest of the class, all right? So like, for example, if I write down on the board here L2, all right, what I mean is for you to go to the logarithms section and look at number 2. There are actually 2 formulas there. There's this one, and then next to it there's another one that says this. You should probably have these hardwired at some point, yes. Now, I've been telling you you can do cheat sheets, and I've been giving people bonus for not using one on the test. I probably will use the same tactic on the next test, so that if you've got these memorized, I kind of reward you for that. So does everyone understand if I write L2 that I'm meaning to look at one of these 2 formulas? Understand? Okay. All right, so these properties of logs come into play throughout the rest of your mathematical life, whatever that is, okay? I know like in my Cal 2 class, we used that property that I just wrote on the board. We used that yesterday, and I didn't sit there and review the properties of logs. I just assumed my students knew what these logs are. So that's the importance of us seeing it in this class, is that when you get to some other class and they do something weird, you're like, what the hell is that? It's probably one of these properties of logs, all right? So let's start out with the first property of logs. Now, I know that these are written down, but I want to explain what they mean, all right? So this is what's written down on property 1. Now, I would prefer if you throw a parenthesis around that like this. What this first property is saying is that if you ever see a single logarithm, right? This is actually called, what is it when we write ln and it's the natural log, right? What's the base of the natural log? That's the base of log. The base of the natural log is e, right? So this is a very special log, right? The natural log of 2 things being multiplied, right? You see the product in there? That's multiplication. That, according to this property, can be rewritten as natural log of x plus natural log of y. Okay, so a single log with multiplication inside becomes 2 logs with addition, right? It works the other way around. If you ever have 2 logs with addition, you can convert it into a single log with multiplication inside. So both directions work here. Whenever we go from this direction to this direction, we usually call this expanding, because you're starting out with something, just a single term, and you're splitting it up into 2, so you're expanding it out. And then when we go the other direction, we call this condensing. That makes sense? That language makes sense to you? Now that's the way that property works for natural log, but this property works for any log, with any base. So that's what the other one on the other side represents. So the other formula 1 says, okay, well this will work for any log. So do you all see that this is the same exact property? Do you all see this is the same exact property? If you replace A here with E, it's this formula, isn't it? Replace this A with E, and you have this formula. If you replace this A with 10, it would also still work, right? So this is the more general form of the formula. This is the specific case where we're using the natural log. All right, so that's property 1. Now, if property 1 says that if you have a single log with division inside and you can turn it into 2 logs with addition, then what do you think division inside of a log turns into? Subtraction. And this is property 2, right? Yes. Minus property 2. So again, single log, division inside, can split into 2 logs with subtraction between the 2. Now here you do have to be a little careful, because whatever the numerator is here is the first log that appears. Whatever the denominator is here is what the second log is. You can't mix those up and say, oh, this is y, over here and x here. Got to follow the format. This goes first, then this. It's still called expanding and condensing. And then if we do it for, in general, x over y, this turns into minus. Okay, so that's your second property. So far, that all right? All right, the third property, and one of the most important properties of logs. So this is a really important property, and put a star next to it. If you have log of x, and I'm going to put that in parentheses, raised to the y, what does this property say you can do? Look at the property. What is it saying you're allowed to do? So what happened to the y? It comes out front. Y times natural log of x. So if you have a power, on the argument, right? The argument of this log function is x, isn't it? If there's a power on that argument, the power can come out in front. That's weird, huh? Why can you just drop the power out? That's kind of strange, isn't it? We can actually do it. Watch. What does x to the y mean? What does that mean? This really means x times x times x times x. And I keep doing that until I get to my last x, right? And how many of these x's should I have? Y of them, right? And then the first property said that if I ever had multiplication inside of a log, I could split it up into what? Addition, right? So when I had two things inside, like if I had x and x, I could turn this into what? Natural log of x plus natural log of x, right? But if I have three of them, natural log of x plus natural log of x plus natural log of x, if I do y of them, then I should have natural log x plus natural log x plus natural log x. And how many of those will I have? I will have y of these, right? So isn't that the same as y of those? That's what this means, y of the natural logs. So it's the first property being used, but it's very, very powerful. That formula is very powerful. All right, and then it also works if your base is anything. So I'm not going to write number 3 here again for log base A. Do y'all make sense? I mean, does that make sense to you? All right, the next property is also important. They're all important, damn it, or else they wouldn't be on here, right? Okay, fourth property. Natural log of e to the x equals, according to the property, what? X. Why? Let's look at the other property for a general base. It's it's log base A of a to the x equals x. Isn't that what property 4 is there? So if I put this on the board right there, what's the question I'm asking? A to what power, right, is what? A to the x power. Wait, hold on. A to what power is A to what? The x power? That's the question I'm asking? So that means that this has to be x, right? That's what we're saying. You could also say it with that loop, right? A raised to the x equals A to the x. Okay? Now, there's something more profound happening here. All right? There's something way more profound. We missed that. I'm telling you, we missed you guys. Okay? A to the x is what type of function? Exponential function. Is an exponential function 1-to-1? So it has an inverse. What's the inverse of the a to the x function? Log base a, right? So you're telling me that this function a to the x has an inverse, and its inverse is log base a of x, which is this, right? So aren't you plugging the exponential function a to the x into its inverse? Yes? And didn't we say that when you plug a function through its inverse, f of g, or f of g of x should spit out what at the end? X. Right? That's exactly what happens. X goes into the exponential function. That answer goes into the log function. The whole result is that nothing happened. All right? That's what that property is. Now, why is that property working here on this top one? Because what is this base for real? Like, what is it? It's log base what? E, and then e to the x. Do you see why that is true?
See, that makes sense.
Yeah. So this, when you don't write the e in there, you sort of like lose sight of the fact that it is base e, which is why I don't like the shorthand notation. I prefer if we just wrote the base every single time, but that's not the convention that we use. So I know. Okay. What's next? 5. Equals x. And then the more general formula is what? A to the log base a x is x? All right. Right, so this is a very important property also because anytime you raise a to its inverse function, it's going to spit out the x. All right? Let's see, are we done with the properties? For those, right? Now there's useful identities. So I'm going to write down for these, so like if I wanted to use a log property, I told you I'd write L2. But if I'm going to use an identity, I'm going to write I, okay, for identity. And like I1. So let's look at I1 here. It says natural log of E equals 1. Why? Why is that true? Okay, because this is really log E, log base E of E. E to the 1, right? Look, this is really E to the 1, isn't it? So this isn't this actually property, which property is this? This is property 4, right? This is property 4, isn't it? Instead of saying log base E of E to the x is 1. So it just spits out the 1. Now, the way most people remember this is just that, hey, look, whenever you see natural log next to E, they wipe each other out and it's just 1. But this is technically what's happening, all right? You're saying e to what power is e to the first power? Well, e to the first power is e to the first power.
All right.
It's almost so subtle, you know what I'm saying? It's almost so obvious it's confusing sometimes. Yeah?
So many words to say one.
All right, what about the next ln? 1 equals 0. Now, you can do the exact same thing. This is really log base e, right, of 1. And so we're saying e to what power is 1? 0. We said that for any log, right? Didn't we say for any log, if you plug in 1, you get 0? Yeah? Okay. All right, that's it. Those are the properties. And with that, we're going to get to some examples, and we're going to start getting weirder and weirder. All right. All right, so let's take a look at this. This example, find the value of log base 3 of 3 to the 71st power. Anybody got it? $71. The answer is 71. What property did you just use? It's on here. It's L4. This is from L4. Do you see it? Everyone see L4 on there? All right. I'm not going to write the property next to this every time because we don't have time for this. That's property 4 I'm talking about. When you have log base a of a to the x, the answer is x. I have log base a to the x, the answer is x. Now, what if this number down here would have been 4? I couldn't use the property, and I wouldn't ask you that question. So it was very important that that 3 was there. How about, I'll do another one. Find the value. We'll call that part A. Part B, how about natural log of e to the negative 21? Just negative 21. Because the property I'm using there, is that the same property? Yes. That's L4 again. Okay, let's try something a little more challenging. All right, so next one for C, we'll call this C. 5 raised to the log base 5 of 6 plus log base 5 of 7. So you see all that log stuff? All of this is in the exponent of the 5. So it's 5 raised to all of this. So any idea where we can go from here? Okay, so you're seeing that I have 2 logs, right? And they're added together, so I could push those together. Does everyone agree with that? So this is equal to 5. You're saying a single log now, right? Log base 5. And then what goes in that log? 6 times 7, which is 42. Everyone see that? What property was that, Nathan? To go from here to here. Was it L1? It was L1 backwards?
It's like 5.
I mean, what we just did was
Yeah, that just from here to here was 1, right? That was property of logs 1, but going backwards, right? From the right side to the left. So we were condensing, weren't we? So what we did, technically, when we say this, is we condensed these 2 logs, right? And now, to the next step, what do you got?
I have a question.
Okay.
If you have the base and then log of the exact same base, couldn't you at first like pretty much cancel them out and then just multiply the last 2 numbers up top?
That's a good question. You could do that if it was just this. You could say 5 to the log base 5 of 6. These would cancel each other out, and your answer would just be 6. But you can't cancel them individually.
You'd have to add them together first.
You have to put them together first. So you have to have a single log before we use the next property. Which is what property are we going to use to go from here to the next line? 5. Property 5? L5? And so what does it turn out to be? Just 42. Because you have the same base here, right? You're raising 5 to a log, but that log is base 5. Those are inverse functions. They kill each other off. You get the 42. Okay? Questions on that? No? Okay.
I thought you said it was going to be tougher.
Well, they're just going to get stranger, all right? I didn't say necessarily tougher, just stranger. All right, so this next problem is I want us to, it's a different example, express as sum or difference of logs. So log base 2 of a over b squared. How many logarithms do you see there? Just one, right? The instructions are to express this as the sum or difference of logs, plural. So I want you to somehow pull this apart. Yes?
Would be log base 2a plus log base 2b squared.
Minus, because we have division. Yes. So we are actually going to be using the second property of logs that says if you have a log with division inside, this can split up into two logs with subtraction. Yes? So this becomes log base 2, and which one came first? The a, and then minus log base 2 of b squared. And so from that step to this step, use the logarithm formula 2. Yeah? Anybody see anything else I might be able to do here?
Well, now using b squared,
Yeah.
get rid of the b squared, right?
How do I get rid of the b squared?
I don't remember, but I know you can do it.
Now be careful here.
Because that, it loops or something. Isn't that an inverse or something?
If we have to be careful. If this was 2 and this was 2, we could use one of the properties. They're not both 2 though, right? This 2 is up here. Wait a minute, hold on. This 2 is, that's right. This 2 is on the argument, right? The 2 can come out front.
Just in front of that.
In front of just that logarithm. So this 2 is going to drop out right in front of that negative sign. And so what we get is this. Log base 2 of a minus 2 log base 2 of b. And now that is fully expanded out. So this is L3 right there. All right, so this is what we call, I said this is the instructions in the book. They say to do this. But the terminology that I like to use here is I would just write the instructions to expand. Expand this log. Expand it out. Now you have multiple logs. Sometimes in later math classes, we get expressions like this that, yeah, sure, this is, this is whatever it is, but it's easier for us to do what we're trying to do. It's hard to tell you what I'm talking about because you wouldn't know what I'm talking about, but sometimes it's much easier to work with this than it is to work with this. So what we do is we rewrite it first. All right, let's do another one of these. This time I'm going to let you work on this yourself a little bit, and let's see who can get this all the way to where it needs to go. And before I give you the problem to work on, I want to ask you about this. We have a formula for this, don't we? Like a way of rewriting that?
Yes.
We have a formula for when there's division. Okay, do we have a formula for when there's addition or subtraction inside the log?
Yeah. Wait, no.
Is it on your sheet? No. So, if you ever see two things inside of a log being added together, you cannot split them up. That's what it is. They're stuck, okay? The only way you can split a log up into two logs is if there's multiplication or division. All right, so with that in mind, I want you to try and expand the following logarithmic expression. It's going to be the natural log of x squared times the square root of 1 minus x. So we'll see, we'll have a competition to see who can take that the furthest.
I have money on Jordan.
All right. If you want to ask me a question whether or not what you're doing is right, you can raise your hand. I don't mind coming by and telling you if you're on the right track. I'm just going to take a look. Okay, good.
So I'm stuck with this, but I was also wondering how to get rid of all that.
Not here, but here. Isn't that a power on the x right there?
Yeah,
So-
so it's going to come out to 2.
Oh yeah, I'm sorry, I didn't see that.
Yeah.
This one right here. What is the square root? Isn't the square root really a power? It's right. So if I have like x square root of x, this is really x to the 1/2, isn't it?
Yeah.
So do that instead. Let me look at yours again. You had that in parentheses. Yeah. Okay. Anybody else? You have a question?
I don't know how to do it. Yeah.
Okay, you're good here
Oh, that's good so far.
so far. Yep.
Okay.
Now see if you can go any further with it. Okay, good. See if you in the right direction. See if you can go any further with that. Good. You can go a little bit further.
Further with
Think about that. Look what I wrote up there on the board.
That has to stay.
Parentheses. Yep. That's good.
Wait, what? Spiral.
Yep. That's good. That's right. You don't need the 1/2 in parentheses, but it's not wrong to be that way. But you have to have parentheses around that. So that is correct. Good. You want points for being the first one? All right, I think most of you are here. Most of you are there? I'm going to do that on the next step. How about this? Remember, the square root is the same as raising something to the 1/2. You don't have to do it first, but watch. What am I? Yeah, I'm going to do on the next step. What am I going to do? I'm going to drop the 2 out in front, and I'm going to drop the 1/2 out in front of this log. Yes? Yes.
Because it's 1 minus x to the first, which is inside the radical. Or is the radical?
Say it again.
So 1 minus x is the raised to the first, which is inside the square root.
Yes, it's the radicand. Can't do anything with it. No.
Is that what you're talking about earlier?
Yeah, that's. I just want to be careful. That's it. This is it. This is as clean as it can be right there.
Oh, okay, so you brought the 1/2.
Brought this 1/2 power out front.
And that's as simple as it can be. For me, it was like, what's 7 times 5?
You ready for another one? Okay. Okay, I want to erase the answer, but I want you to try to expand the next one. You ready? Log instead of natural log. X cubed times the square root of x plus 1 over x minus 2 quantity squared. So, yeah, since there's no base, this is really base what? 10, but all the properties still work, all the same, so you can still split things up. You don't need to write the 10. Nope, you do not need to write the 10. Just like over here with natural log, I didn't ask you to rewrite it as log base E, just leave it as natural log. Can I erase the answer up here now? Okay. See what y'all can do with that. No, you may wind up with more than 2 logs. Yes. You could have 3 logs, 4 logs, 5 logs. It's just not, it can't be 1 log anymore. You got to split it up. Yep, I will come check. So let's see. That's good. You had log, right? Yes. Where you at? Yep, good.
Wait, wait,
You're on the right track so far. Yes.
I was just making sure.
Yep. So your first line is correct. What is the operation between that x cubed and that root? Okay. Yes, good.
It is?
Yep, that's right. Uh-huh. Yep, that's it. Yeah. 2. You just forgot to write the 2 in the original problem. See how I have the x minus 2 squared? Look up here. Right here. You just didn't write that in the problem.
Is it this whole product subtracted by this?
And then subtract. Yeah, so you don't need these parentheses because you have addition. It's just going to be this plus this minus that.
Okay.
It's not wrong to have that,
Yep.
but it's not necessary
Okay, I
either.
thought it was like the whole product of that.
You're good. If you got this one already and you want something a little more challenging, I'll give you something a little more challenging. So this is just if you want to try it, okay? That's like a challenge problem right there. Anyone else want me to look at their first one, or are you?
Oh, wait.
Okay, good. Yep.
Do you do this right?
Yes.
I'm gonna put-
Yeah. That's
There.
right.
Okay.
Yep. Good.
Do I keep them in the parentheses?
The x minus 2 has to be in parentheses. That is. Here. Okay. This line right here is correct. This is correct. Okay. This is a product right there. And because it's a product inside of a log, it splits into 2 new logs. Look over here.
What? Oh.
Share your knowledge.
Okay. Oh, I see.
Do you see it?
Yeah.
Okay. Yep.
It's not 3 going.
That's a cube root.
God, see, that's what I said.
Yeah. That's a cube root.
So,
I have a question.
Okay.
So this will come out here, right?
Mm-hmm.
And then do we add the ln or just start?
Just, yeah, the root, the cube root, you've taken care of with the 1/3. So
Right.
just rewrite everything else
as
in parentheses. Yeah.
Okay,
Uh-huh.
okay.
Yeah.
So now I'm going to separate this, but does that
It's going to follow you the whole way.
both in lieu?
It'll go to everything.
So it's going to be 1/2 ln and then that, and then plus
Mm-hmm.
1/3 ln that,
Yeah, do the division first.
or minus.
Yeah, and then the 1/3, and then, yeah. That 1/3's going to be there the whole time. Yeah.
Okay, so it's
Yeah.
gonna like distribute.
I'm going to write down the answer to this one. I'm going to work it through. Well, you don't have to look up. Let's see.
distributes like this.
Hold on a second. Yes.
Okay, stay with
yes.
that one, and then I'll
And
just
it's going to stay
separate
when you
those.
split these.
Oh,
It's
when-
going to stay and
both of
stay.
them, okay.
Yeah. Let me work it first, and then we'll compare. Yeah.
Just write the answer to the one you wrote.
Hmm?
Oh, right. Gotcha. I could do all that on my paper.
That's the correct answer up there.
Brandon, give me like 10 minutes to write all that.
It's all on video. I'm gonna talk about this one. I'm gonna talk through it, okay? Because I don't want to take. We still have more time. I'm sorry. So look, this is the original problem. That's the original problem. This big cube root is on the entire thing, right? So I'm going to rewrite that cube root as the entire thing to the 1/3. Right? Square root is 1/2. Cube root is 1/3. Then I have natural log argument to the 1/3. That property, the third property, I can pull that 1/3 out, right? Here's the argument. Now I have division. Notice I couldn't go attack the division until after I got rid of this root. I had to do that first. So now that I have division, I split this log right here, gets split into 2 logs, right? With subtraction between them. But since there's a 1/3, the 1/3 has to distribute to each one. This log has a product in it right here. So it splits to 2 logs. And the 1/3 goes to each one of them. Then I had minus. This log has a product in it. It splits to 2 logs, so that's addition. But you're supposed to be subtracting. So that's why I put a bracket here. You're going to wind up subtracting both of these. And the 1/3 goes to each one. And then the next step, I brought the 2 out front, which gave me 2/3, natural log x. I brought the 1/2 out front. 1/2 times 1/3 is 1/6. And then here, I brought the 4 out front, 4/3, and then I subtracted it. Then I brought the 3 out front. 1/3 times 3 is 1, so it's not there, and then I subtracted it. That's it. So this would not be a problem that I would give you like on a test. This would, But if you can do this one, you're definitely in good shape. That might be a bonus type thing, yeah. I might make it a little harder, though.
I just took do it the 1/3 to everything and broke it up the way you normally would do. I thought it was that without it going bracket and stuff.
Uh-huh.
So I just put 1/3 in front of everything.
Yeah,
Before you
that's
erase
fine.
it, isn't that supposed to be the very last one plus LN? X minus?
Right here? Well, that's what's so important about this. See the subtraction? You're subtracting this whole thing, right? And if it splits into 2 pieces, you have to subtract each piece. So this negative sign distributes here and here. That's what usually gets people, that 1 minus sign right there.
I thought you said this one was really hard.
Which one? It was more challenging, right?
That's it.
That's it. No problem, huh? Usually these problems, the way they work is that Students either really struggle with them or it's like makes perfect sense and it's easy to grind out. But if it's still, you're still struggling with the properties, until that clicks, you run into some issues. All right, well, let's do the opposite. Let's condense. Now, in the book it says write as a single log. So we'll start off kind of easy. Not to say that they're going to get really hard, because apparently there's nothing that's hard for anyone in here. Everything's easy, right? No.
100%.
Okay, that's a U and that's a V. This is a U and this is a V. Next problem. How many logs do you see? We need one, right? So you might be thinking right now, I've got subtraction between two logs, so I can put it together, right? Subtraction between two logs goes together into one log? And it becomes division inside of one log, right? Except that there's one issue. You have to take care of the 2 first. So if we're going backwards from what we had been doing, I'm going to push that 2 back up as a power to the U. So my first step, before I put these 2 logs into one log, is to push the 2 onto the U. And only onto the U, right? Not onto the V. And then put them together into one log. So a single log, base 3, division inside because it was subtraction. What's on top? U squared. Bottom, V. That's it. You're done. Was that all right? Any questions, Jordan? You good? If there was a 2, the question is, if there was a 2 here, yes? Then I would have done a 2 here, and then I would have done a 2 here, and perhaps, I mean, that would be fine, but perhaps I would write then log base 3 of U over V squared, because it's squaring each one, if there was, but there's not, so. Yeah, if it was like 3, then this would just be 3, and then that would be 3. Just leave it there. Yep. Okay. Let's do another one. Condense. You're going to like it. Log of x squared plus 2x minus 3 over x squared minus 25 minus log of x squared plus 7x plus 6 over x plus 5.
So until Friday to drop this class, right?
You have till Friday, but I need to know by 8 o'clock Thursday.
8 a.m. or 8
p.m. Technically, you can actually, as long as there's an email that comes before 5 p.m. on Friday, as long as that happens, I'm just saying for any class you're in, if there's an official record that the student requested to be dropped before the deadline, then they'll do the drop, even if it's a little late. As long as there's something written or documented before 5 p.m. Friday. Yes?
You're going to have to do times by the cognitive, right? There's actually algebra you have to do it.
Yeah, there's going to be some algebra here.
Okay,
So
just making sure I'm on the right track.
everyone see two logs being subtracted? Right? We don't have any numbers in front to worry about first.